Hi, everybody. We're very pleased to present to you our research. I am Marie-Laure Gascon, private conservator in painting conservation.
And I am Joséphine Delangen, private textile conservator. And we both graduated from the Institut National du Patrimoine in Paris last September 2024. This institute is the main training school for conservator in France, with an average of 20 graduate students per year divided into 7 specialties. During our last year of training, we are in charge of the study and restoration of an object from the French Heritage Collection, as well as leading an experimental protocol related to an issue linked to her rock. As a result, we became interested in the use of the digital image correlation, the IC, to address conservation issue in your 2 specialties.
So you guys already know maybe about DIC because we've heard of it yesterday. So just as a quick reminder, we have an example for example, a textile piece where we put weight gradually, and then we take picture at every step. And then we compile all the pictures together, and then we get mapping. For example, here you have a mapping of displacement. So for our 2 tests, we use only one camera because it was 2D correlation, and correlation software, which was Istra 4D. So it requires real little equipment, but for interpreting the results, it requires mechanical knowledge and also a little bit of experience. So now Joséphine will present to you her case study.
For my final dissertation, I restore a cyclist world jersey worn by Julien Moineau in the 1935 Tour de France. The jersey kept at the Musée National du Sport in Nice had a serious stability issue. In 2020, insect infestation damaged it, and by the time it arrived for restoration in September 2023, it was in poor condition. There were many holes and lacunas, its structure was weak, and handling is risky for the damage. This issue also affected its appearance, making it harder to fully understand the piece. So, consolidating the knitted fabric was a major challenge for this restoration project. Knit fabric is made of one or more threads that loop around each other to create stitches, which make it very flexible. Because of this flexibility, it can be consolidated using the same method as less flexible woven fabric. Only a few studies worldwide have looked at this issue, focusing on the question of removability and identification, but none have scientifically tested the mechanical effect of different techniques. To find the best restoration method, we conduct an analysis of the mechanical behaviors of the mesh consolidation techniques using DIC. We concentrate on jersey beading, which was the most affected by the problem in her rock and the most used in knitwear. We wanted her trails to be as close as possible to her rock with the same techniques, the same yarns, and the same density. The latter was created on the mechanical knitting loom with the picket stitches. Stitches are formed using a paddle needle aligned in a needle bed. One needle corresponds to one stitch. Our test pieces were made in collaboration with the École Supérieure des Arts Décoratifs in Paris. Since there was no standard size, we chose a 17 cm square with a 2.5 cm square lacuna in the center. This allowed you to see the effect of each technique without distortion from the edge of the test piece. The 4 techniques selected for testing are consolidation with a woolen cheesecloth support cut on Tobias for more flexibility. Then the support is held in place by a self-crossing stitch made with organza thread. Crochet row knitting is a traditional technique. It involves making a horizontal auxiliary network with a wool thread similar to knitting. Stitches are then created onto this network using a pattern needle. This was completed by two mixed techniques, combining a consolidation support and a crochet knitting filling. The first with the woolen cheesecloth, and the second with the nylon tulle. For each technique, we have the 5 test pieces and the five control samples with no lacuna. For DIC, we place the test piece under tension, hiding weight every 50 grams up to 250 grams, first in the column direction, then in the row direction. Each time we take a photo. These photos are then processed in the software to create color maps showing deformation and displacement. The map shows the movement in the Y direction and the X direction. The displacement map along the Y-axis shows that as we add weight, the test piece stretch, with the lower part gradually changing from blue to red. By taking the highest value, we can create stiffening curve from each technique. In the main direction, we see that all techniques behave similarly to the gray control value. They do cause a slight stiffening, but they don't significantly change how the jersey behave. The difference is only a few millimeters. We see the same in the column direction, where the difference from the black control value is even smaller. Then results alone are not enough to choose the best techniques. Because the main goal of the consolidation is to make the fabric behave more uniformly, especially in the area of with lacuna. We need to understand how consolidation affects flexibility and its ability to restore this uniformity. To achieve this, we examine how the sample behaves under tension. We use the IC to create maps showing areas that stretch in red, indicating positive deformation, and area with compress in blue, indicating negative deformation. In addition to the mechanical impact, we also observe the visual rendering by taking pictures before and after consolidation, consolidation time, removability, by entering the restoration of free test piece shows at random by techniques after DIC and comparing with the pictures taken before and after removal, removal time, and difficulty of realization. A detailed presentation of the result for each technique will take too long, especially for DIC. Instead, we include all the results in a chart with the score ranging from positive to negative. The chart considers key factors for effective consolidation, minimal impact on flexibility, uniformity during tension, removability, and minor factors focus on visual appearance. We also include additional information about removal time, consolidation time, and difficulty of realization. Consolidation with a cheesecloth support and crochet knitting filling is the technique that combines the most parameters. This method has a good appearance, it's removable, and provide better uniformity under tension. The deformation along the Y-axis, that the consolidation main area becomes stiffer, but this doesn't affect the rest of the fabric. In fact, the raw knitting is attached to the support and not to the original fabric. Deformation along the X-axis show a little change around the lacuna, but uniformity remains good. These techniques seems best for consolidating knitted fabric. We use this method to consolidate most of holes and lacuna in our jersey, moving from a simple to complex lacunas. And you can see my end during the consolidating and the result before and after restoration. But our study does not definitely disqualify any of the 4 techniques studied. The tulle baking can be difficult to achieve with the consequence problem of uniformity, but it is the most flexible, so may be interesting for the consolidation of the rib beading. It's the most flexible of the jersey beading. Reknitting alone alters the knitted fabric during removal. It has a little mechanical impact, but remains less interesting than the mixed techniques. The attachment zone of the auxiliary network leads to deformation and significant stress on the rest of the knitted fabric. But its use on the oars remains interesting because the fixation is smaller. Consolidation with the support alone results in rigidity and proximity of the lacuna and the rest of the knitted fabric. But it is the only procedure that is easy to identify as restoration, with the can be desired for other objects. For conclusion, the research done with the IC provide initial answers to a textile restoration problem that hasn't been fully explored, but mass consolidation research is still in the early stage. It will be interesting to continue studying similar techniques for other materials like rib stitch, silk or cotton, and not the mylar case.
So I will try to be quick to fit in time. So I also, for my final dissertation, work on the artwork. This one is a 16th century painting on canvas depicting the Declaration of Christ, and which is kept at the Palais des Beaux-Arts in Lille. It's a copy of an original artwork by Bartolomeo Suardi, known as Bramantino, this one is kept at the National Museum of Art in Bucharest. But on our painting, we have some conservation issues. As you can see here, a lot of major deformation due to the lack of tension, especially on the upper edge, where the canvas was not properly attached to the stretcher frame. So we had to remove the canvas from the stretcher and then reattach it to, in this case, another stretcher frame. But this treatment required the use of strip lining. So understanding what is happening during strip lining was the subject of our study, which is the IC mechanical monitoring of the effect of different strip lining textiles during biaxial stretching. But firstly, what is strip lining? It consists of gluing textile stripes on the edge of a canvas. This reinforces the edge, but also allows us to reattach the canvas to a stretcher frame. And it's an alternative to full lining, as it's offer a more minimal approach when it's possible. The canvas can be reattached via these strips or via other set of strips, which can be added later. So some research were made on lining by a lot of different conservators and scientists, but not so much strictly on the behavior of strip lining. So that's why we were interested in this subject. But what material to choose for strip lining? It seems that there are two schools of thoughts for the canvas, natural fiber or synthetic fibers. They offer some difference here that I won't elaborate too much, but we will use both in our tests. Most of the time, natural fiber is usually more flexible and also more hygroscopic than synthetic fiber. And it seems that the textile strips should be oriented in the same direction to achieve an even distribution of the tension. So we choose to, for our tests, orient all the strips in the warp direction. For the adhesive, a lot of different adhesive can be used. In our case, we use BEVA 371 in film form because it was easy for us to have a good protocol for us for the rest of the test. And it's also very commonly used, at least in France, for strip lining. And so once these strips have been glued, the work can be stretched on a temporary frame. And then the frame is open. so that deformation can be treated. And also the temporary stretcher offer a good tension during treatment support of the canvas support before reattaching it to the permanent frame. So we ask ourselves a few questions here. How are the forces distributed during the extension on the temporary frame? Does the choice of the textile have a significant mechanical impact? How do textiles move and deform? And finally, is it possible to carry out mechanical monitoring directly on our artwork? So to answer those questions, we used the DIC. Because we wanted to only focus on the choice of textile, we made a few selections and we put them through a tensile test to characterize them. We then obtain here curves indicating the flexibility of the material, so their capacity to deform to a greater or lesser extent. Here we can see that the polyester canvas is the stiffest material, and the more flexible ones are the mixed linen, polyester canvas and linen that are even more so at a higher RH level. Knowing this, we began our biaxial testing. So this is what one of our sample look like, with a central canvas that is always linen, the adhesive always Beva, and the different strip lining material that I listed before. We put these sample on a stretcher, temporary stretcher, and then we take pictures before and after stretching the frame. We obtain displacement maps, firstly here. So unfortunately, I don't have a lot of time to discuss all the results. Just to say we have the approximately the same maximum displacement everywhere, which is a good thing. It seems that we have managed to open the stretcher frame similarly for all the tests. So that's a good thing to see. But I want to take some time to discuss about the strength distribution here. So if we look at the non-woven fabric, despite significant strains on the strip, it doesn't seem to affect the central piece, and the load seems to be distributed within the material, within the strip, which in our case is interesting to have a homogeneous result. But on the contrary, in one of our other sample with monofilament strip, the deformation are transmitted to the central piece. So for our treatment, we wanted to use a first set of strip that will be stretched on the temporary stretcher. So a thinner material that can be later used as an interlayer, and a thicker material for the second set of strips that will be used to stretch the painting on a permanent stretcher frame. So for the first case, we chose non-woven fabric for the reason I stated before. And for the second case, we had similar good result with linen and mixed canvas. So for other reasons, mainly the stability of mixed canvas compared to linen, we preferred mixed canvas. And here you have a picture of the two set of strips. During testing, so this is just a special case here, we noticed a strange stain appear in one of the strips here, and it's actually it looks like there's a different mechanical behavior very locally here, and we noticed after the test that a stain of maybe glue or something was in the strip, but we didn't see it before with our bare eyes. But it showed how DIC could be interesting to spot any difference in materials. Of course, there are some limitations to our protocol because it's the short-term tensile behavior. And also our samples are quite simplified because there's no paint or old aged materials. So we tried to use the DIC monitoring on our artwork, and we had this result. So we did the DIC during the treatment, during the stretching of the artwork on the temporary frame. And we are very happy with the result because we were able to map the entirety of the artwork without speckle patterns. So, and also we didn't use any speckle projection in any of our case, Josephine and I. We can spot the higher displacement value because of deformation we've treated. So we knew we're gonna happen in this area. But here we spot higher displacement value that we do not really understand even today. So it will be interesting to look at this result even further and maybe test DIC on other artwork while they are treating on other stretcher frame. In any case, the mechanical monitoring of painting using DIC could give us a better understanding of these behaviors and could help us characterize those historical materials. So we can say, I think, in conclusion, that DIC is very relevant to different conservation fields, as you can see, textile, painting, and yesterday on wood. It's a good tool to choose a conservation technique for Josephine's case, but also for me to better understanding what's happening during treatments. And it was a pleasure to attend to all these presentations, and we can't wait to have some more. And now the interesting part of the before and after treatments photos.
And would like to thank Sandy Lecomte and Julien Colmar for their constant support and supervision. We thank the Getty for invitation, us to the symposium and allowing us to present her research. We also thank the Institut National du Patrimoine for the training, as well as the opportunity to study very interesting cultural objects and scientific topics like this. Et we thank the Palais des Beaux-Arts de Lille et the Musée National du Sport of Nice for their trust. As last but not least, we would like to thank you for your attention.
Thank you to both speakers. Questions?
Hi. Regarding that area of the painting that you had this unexpected strain, it just jumped on me that it's the area where you have a very repeatable pattern on the surface. Have you excluded basically a wrong correlation there? So basically a jump in the pattern being reinterpreted as a movement when it's really a repeat in the pattern?
I'm not sure I understood the question here. It could be because as I mean, it's the first time that I've did correlation images. And also because it was done manually with what I had to manually open the stretcher frame. But I think that there's really something going on here. And also I tried different adjustments and different parameters. But of course, I cannot be 100% sure because I couldn't do that again, of course. And I didn't want to overstretch it. But it's a good remark. And it's one of the limitations is that because it's not done, it wasn't done a lot before, we don't have a lot of experience with that. Yeah. Oh, maybe I just wanted to ask, I didn't show the strain maps here. And I think we had a pretty good result in correlation. I didn't show it here because I didn't know what to say about it because I saw a lot of things. But one thing I saw is that we saw the composition, like the painting, the leg of the Christ and the drapery and stuff. So it showed something. The correlation worked at some point, but I don't have enough knowledge to fully discuss it being 100% sure.
Thank you. I guess just kind of following on from Jasek's comment really is around the textiles as well. So obviously DIC is reliant on the random pattern. And I wonder whether when you've got a very repetitive textile that doesn't have any, it's very repeatable in terms of the structure that you're looking at, whether you are having issues of aliasing across the sample and just talking a little bit about the challenges of looking at textiles with DIC without applying a pattern and using the natural pattern of the textile. Can you expand on that a little bit?
Well, even if it's quite like the pattern is repetitive on a textile, even like in knitted fabric, we managed to see different behaviors, and the repetitive pattern didn't really bother us that much during the test, and the software really did a good job knowing which pixel to see and which pixels were moving at a given point in time. So, and also the thing that because we saw also things that I also saw with my eyes, also show that there has to be a correlation, if I should say, with what I'm seeing and what the software is seeing. And also, I've tried one of the textile I've used, monofilament polyester, is super thin and also shiny. One of my correlation sample didn't work because there were some noise, but the other two worked because I had good enough picture and a good lighting. So I don't think that the repetitive pattern is a problem in this case. Also because here we have the pattern of there's no repetitive pattern here because we took a picture in front of the painting. So.
Thank you. I appreciate it. Thanks.
I think there is maybe a misunderstanding about the question. Have you checked also your fixed point, because your frame doesn't move? So that's a very good actually way to check that your fields that you are showing now, your displacement field, is actually the right one.
Yeah, it's true. I didn't really think about that because, of course, it was my first time doing that. But there are no fixed point. The only fixed point here, it was more arbitrary. But on the other sample, even the frame is moving. So I don't have any fixed point. The only fixed point that I have is me being careful. And also create chalk on the floor to see if I'm moving. But I think the interesting part of the sample correlation software is to compare them with one another. And I didn't want to look at numbers. I wanted to look at general maps. So if it moves just by 1 or 2 millimeters, also I've used on the software, I could remove I could say to the software to remove any unwanted moving of elements. So I managed to do that with the software. So I think the results are telling things, even though I'm not an engineer. I'm not a I'm half a scientist, but I think my protocol was right enough to have result at least to discuss about what we're seeing.
Okay. And can you comment on the use of a color sensor camera on DIC techniques?
All the pictures were then turned in black and white.
Yeah, but your sensor is still a colored, right?
Yeah.
RGB
Yeah.
or
It's-
CMOS sensor. So you do make an error on your geometric areas when you take your picture. There is ways. There is ways to counterbalance this kind of errors, but it's just a check to make that you basically have enough resolution for what you are showing now, your displacement, which is, I guess, in millimeters.
Yeah, it's in millimeters.
So it's it's a lot.
Yeah.
1.2. But I would be extremely careful in the future to use a colored sensor for your DIC technique.
Sure. No problem.
Yes.
Yeah, of course we did white balance, etc., and we did it with our photograph. She helped us really adjusting all the parameters, and we also had a mechanical engineer with us to say what to do.
Okay, thank you. Excuse me, but we have to